I've chosen to include this section in here in our review because it is so critical that you have your assigned numbers correct. Okay, because if you're making mistakes on this stuff, you're killed for the entire course. Let's begin with the rules for addition. If you have a positive plus a positive, your result is going to be a positive. If you have a negative plus a negative, your result is going to be a negative, or a bigger negative if you want to consider it that way. I like to think of this in terms of money. If I've got two bills or two credits coming in, I've got more money coming in. If I have two bills that I need to pay, I've got more debt, and that's my minus sign there. Now, when the signs are opposite and you have a positive plus a negative or a negative plus a positive, I wish I could give you the answer right off the bat. The answer is it depends. Which do you have more of? Do you have more positiveness or do you have more negativeness? And in that case, technically the rules are take the sign of the one with the larger value. In other words, which do you have more of? Do you have more positiveness or negativeness? And that will control the sign of the answer. And then subtract the two numbers to see how far apart they are. Again, if you go with a money model, that really makes a whole lot of sense. When it comes down to multiplication and division, if you have a positive multiplied by a positive, it equals a positive. If you have a negative multiplied by a negative, that is equal to a positive. In both of these cases, we are dealing with the same sign. If the two factors which you are multiplying together have the same sign, then the product, the answer to the multiplication problem, is positive. If, however, you have a positive multiplied by a negative or a negative multiplied by a positive, in both of those two cases you have the opposite sign in your two factors, and the product will be negative. Okay, and you do not want to get mixed up the positive and negative rules for multiplication and division with those for addition and subtraction up above. Note that I can change out this word multiplication for the word division, and the rules are going to be the same. Here is a very easy concept that is sometimes highly misconstrued or misinterpreted. When you are multiplying negatives together, you pay attention to how many of them you have. If I'm multiplying 57 negative 1's together, the answer is going to equal negative 1. Because the first two multiplied together, negative 1 times negative 1 gives you positive 1. But then when you multiply that positive 1 by a negative 1, it changes to negative, and then positive, then negative, then positive. And since there's 57 of them, which is an odd number, that tells you the final product will be negative 1. So what I'm saying here in this property is negative 1 raised to a power will be positive 1 if n is even, or negative 1 if n is odd, which makes total sense, and a lot of people really get that. But this is where we start to have trouble. People get confused between the difference of these two. They are not both going to equal negative 16. This first one, negative 2 to the fourth, is like negative 2 times 2 times 2 times 2. Only the 2 has the exponent applied to it, not the negative out front. This is like having negative 1 times 2 to the fourth. And so this becomes negative 16. Whereas negative 2 quantity to the fourth power is negative 2 times negative 2 times negative 2 times negative 2 again, which is positive 16. Okay, it's this second problem here that is relating to that rule up above, not the one over here at the left. Sometimes I like to say that exponents are nearsighted and they only can see what's directly next to them. For example, the one I'm pointing to here, the 4 only applies to the 2, not to the negative. Whereas this one here, the second example, the 4 is being applied to the entire negative 2. If it's nearsighted, it's kind of like these parentheses are the eyeglasses that tell you, hey, you can look at the whole thing. Now if you think about it, if you had xy to the fourth, you would understand that only the y is being raised to the fourth power and not the x. Well, that's kind of what's happening here with negative 2 to the fourth without the parentheses. The 4 is only being applied to the 2, not to that negative 1 out in front. Now, these properties are always in operation.